Good day viewers, welcome to my channel Mathematics Clinic by Tutor Chris. So in today's video, we'll be solving this variable differential equation together. The problem says that we should find the y dx if y equals to open bracket x minus 1 all over x plus 1 close the bracket squared. Alright, whenever you're having this kind of function which is a fraction, it is advisable to make use of the quotient rule. That is a function that you cannot express as something to the power of another. That is what I'm trying to say, is that there is a fraction. So it is advisable to make use of a quotient method. But this function now is not just a fraction, but it's having a power, raised to a power. So that tells us that I'll be making use of the chain rule, which is also known as the composite function. But the issue we'll be having is when I'm going to find my du dx. For everything inside this bracket now, to find the du dx, it will be very difficult. So I'm going to also make use of the quotient rule to find the du dx. Alright, let's dive in together so that you understand what I'm trying to say. Okay, so don't forget that the formula for the chain rule, that is the composite function, is same thing as dy dx, which is equals to dy du multiplied by du dx. Alright, this is cool. Now let our u be everything inside our bracket, that is x minus 1 all over x plus 9. Alright, you can see that to find our du dx, to differentiate u with respect to x here, will be very difficult. So I'm going to make use of quotient rule to find the u dx here. So I will leave only u and then I will go to my y now. So y, since we said u is everything inside this bracket here, so y will be equals to u squared. That is u to the power of 2, and it is easy to find my dy du. That is differentiating y with respect to u, which will be equals to 2u. That's fine. Now I'm going to look for my du dx, and for me to look for du dx, this function is now in form of a fraction, and that means I'm going to make use of the quotient rule. And the quotient rule says that dy dx is equals to v du dx minus u dv dx, and everything all over everything all over v squared. Everything all over v squared. Alright, so we're having this all over v squared. All over v squared. Alright, so now I'm going to substitute this upper part of the fraction, which is known as the numerator, that is x minus 1, to be my u, and the denominator, the lower part of the fraction, to be my v, which is x plus 1. So I can find my du dx, my dv dx, and I will be able to obtain my v squared. So now my u is equals to x plus 1, and if you differentiate u with respect to x, that is, you differentiate this x with respect to x, now I'm going to obtain 1. And if you differentiate the constant, this is negative 1, sorry, and not positive 1. This is negative 1. This is negative 1. That's the upper part of the fraction, so I'm having negative 1. So if we differentiate -1, which is a constant with respect to x, we are going to have 0. So du dx is equals to 1. Now my v is equals to x plus 1. And if we differentiate v with respect to x now, that is differentiate this x with respect to x, I'm going to obtain 1. And you differentiate positive 1, which is a constant with respect to x, I'm going to have 0. So the u dx and the v dx is 1, 1. And my v squared, of course, now will be equals to x plus 1 squared. Alright, so these are what we're having, and I will be going to substitute all these variables back into the formula here. So I will have to go to the next page now. Alright, don't forget that our u is equals to x minus 1. Our du dx is equals to 1. Our v is equals to x plus 1. And our dv dx is equals to 1. Our v squared is also equals to x plus 1 squared. So now I'm going to substitute this into the formula. So dy dx, don't forget we said that for the quotient rule, dy dx is equals to v du dx. What is our v? V is x plus 1. I'm having x plus 1. And my du dx is 1. So if I multiply 1 with this, it's same thing. So I'm still going to have this, okay? Minus u dv dx. This is our u, x minus 1. Multiplied by our dv dx, which is 1. So I'm still going to have x minus 1, okay? All over v squared. This is our v squared, that is x plus 1 squared. So I'm having x plus 1 squared. Alright, this means now that our dy dx will be equals to, if I open this bracket now, this will be x plus 1, and then I use this negative 1 to open this bracket, that is negative multiplied by positive x. I'm going to have negative x. Negative multiplied by negative 1, I'm going to have positive 1. Okay, all over x plus 1 squared. If you look at this now, we're having positive x here and negative x. They are going to cancel out each other. And we're having positive 1 and positive 1, which will become 2. So my dy dx will now be 2 over x plus 1 over 2 over x plus 1 squared. Alright, so I'm going to substitute this now back into, this will now be my du dx we are looking for since morning. So I'll now go back to that first equation where we are solving for the making use of the chain rule, which is also called the composite function. So let's go back to this page. Okay, so now we said when we are making use of this composite function, that is the chain rule, we said that our u is equals to everything in the bracket, which is x minus 1 all over, let me quickly clean this. We said that our u is equals to x minus 1 all over x plus 1. Now we have gotten the value for the u dx to be 2 all over x plus 1 squared. X plus 1 squared. That's our du dx. Now we know that our v, when we are making use of the chain rule, our v is equals to u squared, which we have known already, and our dy du, that is differentiating y with respect to u, is equals to 2u. Alright, and the chain rule says that the y dx is equals to dy du multiplied by du dx. This is fine. So now I'm going to substitute all these values back into this formula. What is our dy du? Our dy du is 2u. Don't forget that. Multiply by, what is our du dx? Our du dx is 2 over x plus 1 squared. So I'm having 2 all over x plus 1 squared. Alright, so now if you multiply this 2u with 2, we are going to have 4u. So this now tells us that our dy dx is equal to 4u over x plus 1 all squared. Now I can substitute the value of u back. The value of u is x minus 1 over x plus 1. Alright, let me go to the next page so that you can see it clearly. Alright, so my dy dx now will be equal to 4 into bracket x minus 1 all over x plus 1, and then this will be all over this will be all over, this will give us all over x plus all over x plus 1 squared. Okay, all over x plus 1 squared. Alright, and this now implies, of course, that our dy dx is equals to 4 into bracket x minus 1 over x plus 1 multiplied by 1 over x plus 1 all squared. Okay, so now 4 into x minus 1 multiplied by 1 is still going to give us so this now tells us that our dy dx is equal to 4 into x minus 1, because if we multiply 4 into x minus 1 with 1, we are going to have 4 into bracket x minus 1. Okay, so this is divided by, oh, what's wrong with this? Okay. Alright, so we are going to have this all over x plus 1 multiplied by x plus 1 all squared will give us x plus 1 cube. So I'm having x plus 1 cube. And you can leave your answer like this and leave it here. Alright, so if you like this kind of video, don't hesitate to subscribe to my channel, invite your friend, turn on your notification, so whenever I upload a video, you'll be among the first to enjoy. Thank you. See you next time.